welcome to my page on YouTube. Today we'll be looking at laws of set. There are 7 laws which govern set, but today I'm going to be taking 3 out of the 7. So let's start. We have, let me list them, this is the 7th out. We have the idempotent laws. We have the associative laws. We have the commutative laws, and we have the distributive laws. We have the De Morgan's laws. We have the complement laws, and lastly we have the identity laws. But I'm only going to be taking these 3 for today. So if you want to enjoy more of my videos, kindly follow me by subscribing to this YouTube channel. Okay, so let's start with the first one. The first one is simply idempotent law. Idempotent laws. Now, what does this law state? This law states that when you have A union A is equals to A, and also when you have A intersection A is equals to A. This is what the law is actually talking about. A union A is equals to A. A intersection A will also equals to what? A. And let us verify this with a simple problem. Okay? Given that A is equals to 1, 2, 3, and another set A is equals to 1, 2, 3. Of course, if you have A equals to 1, 2, 3, you also have A equals to what? 1, 2, 3. Are we together? Okay, so let's start with this before this. A union A, we say is equals to A. Now, A union A simply means what is here and also what is here by combining them into a single set without repetition. So if I combine the two, I will have 1, 2, and 3. So which is same thing as the value of what? Set A, the element of what? Set A. So that means A union A equals to A has been verified. The other one is simply A intersection A. Now, what do we mean by intersection? Intersection simply means what is common to A and what is also common to this A. So, of course, what is common to this is also common to this. So, it's simply going to be equals to what? 1, 2, and 3, which is equals to what? A. Please, are we following? Okay? So, this and this has been verified by the idempotent what? Law. The second one is simply associative law. We have the associative laws. Now, associative law states that when we have A union B union C is equals to A union B union of C. And also when you have A intersection B intersection C is equals to A intersection B then intersection C. This is what the associative law is talking about. A union B union C is equals to A union B in bracket union C. Then also A intersection into bracket B intersection C is equals to A intersection B in bracket intersection C. Let me also give a simple problem on how this law is being verified. Okay? Consider that A is equals to 1, 2, 3, and B is equals to 4, 5, and 6. Are we following? So we want to verify this and that this is equals to this. So let me start from the left hand side first. A union B union C. Now, for me to solve this, I would like to get, it's always best you solve the one in bracket before the outer one. So the one in bracket is simply B union C. So B union C, okay, let me give, okay, sorry, there should be an element C too. Let's say the element C is 7, 8, and 9. Sorry for that. Okay, so now B union C means we combine this and this together. Combine this and this together. Combine this and this together without repetition. Okay, so if I combine them, I'll have 4, 5, 6, 7, 8, and 9. This is what I have for that one. So union of A, that means union A. That means I'm also combining this element here with A without repetition. So if I combine this with A, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So A union B union C is equals to 1, 2 to 9. This is what we have there. So also, if I consider this side, let's see, maybe this side is going to have the same result as this. That's the meaning of this law. Okay, we have A union B union C. Are we together? Okay, so union A union B, I will solve the one in bracket first, like I told you before. So A union B means you are combining A and B together without repetition. So if I combine this and this together, I will have 1, 2, 3, 4, 5, and 6. Are we following? Okay, then union C. So I'm also joining it with C, which is 7, 8, 9. So this becomes 1, 2, 3, 4, 5, 6, 7, 8, and what? 9. So therefore, A union B union C is also equals to 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the law has been verified that this is equals to this according to associative laws. Are we together? So let's take the other case where we have something like this and something like this. Okay, permit me to wipe off this part. Okay, let me just no need to wipe this thing. Let me just clean this part off since we have verified this already. Okay, let me just clean this part off. Very good. So now we want to verify that A intersection B intersection C is equals to this place here. So again, I'm taking the one on the left hand side. So the one on the left hand side is A B intersection into bracket B intersection what C. So I'll solve the one in bracket first. Are we together? So the one in bracket is B intersection C. So what is common to B and what is common to C? You can see there is nothing common to B, there is nothing common to C. So this is actually what? Empty set. Are we following? That is empty set. Also, intersection A. What is common to this empty and intersection A is still going to be what? Empty. Because there is nothing common to them. So this is for the one on the left hand side. So the one on the right hand side now is simply A intersection B intersection C. So I will solve the one in bracket first too, which is A intersection B. So A intersection B, what is common to A and B is also what? Empty. Then intersection C, what is common to them is also going to be what? Empty. So therefore, this is empty. This is also equals to what? Empty. So the two has been verified. So lastly, we have the commutative law. Okay. Commutative law. Now, when you talk of commutative law, this law states that A union B is equals to B union A, and also A intersection B is equals to B intersection what? A. That is commutative law. So let us verify this with a simple problem as well. When we have A to be 1, 2, and 3, and we have B to be 4, 5, and 6. So we want to verify this. According to commutative what? Law. Are we together? So therefore, A union B, I'm taking the one on the left hand side first. It means you are combining A and B together without repetition. Now, we have 1, 2, 3, 4, 5, and what? 6. Are we following? Then on the right hand side, we have B union A. We're also combining B with A, so which is containing the same element, 3, 4, 5, and 6. I only arrange it. It doesn't mean whether it's not organized. As far as they're having the same element, they are said to be equal. So this is for this. So this and this, they are the same. If you are to get for this one, A intersection B means what is common to A and what is common to B. According to what you are saying here now, nothing is common to A and B. This is empty. So also B intersection A, nothing is common, is also equals to what? Empty. So the law of commutative has been verified. The law of unipotent law has been verified. Associative law has been verified. Please, if you want to enjoy my videos, kindly hit the subscribe button like I've said before. And if you have any question on these particular problems, you kindly drop in the comment section, and I'll see you guys in my next class. And my next class will be based on distributive laws, the Morgan's law, complement laws, and the identity laws. So bye for now.